How do you keep track of everything that a program is doing when it becomes very large and complicated? In this video, we'll learn how to modularize our code by writing functions in C++. Hello everyone, my name is Mike and you're watching Polymath Unlimited. In this series, we are learning the C++ programming language by making our own Sudoku game. In the last video, we got the basic foundation of our game up and running by programming the game loop. In this video, we will start adding more features to our Sudoku game. We will begin by writing code that will enforce Sudoku's rules. Moving forward, our program will quickly become fairly large and complex. It will therefore be beneficial to modularize our code, separating it into smaller chunks that each perform a specific task. That way, if something in our code is not working as we would like it to, it will be much easier to debug a series of shorter code sections than it is to debug one huge unwieldy program. To do this, we will use functions. We have actually already been using functions in our code. The main function in each of our programs is a subroutine that is called by the operating system when our program launches. By looking at our main function, we can get a general idea of the syntax for creating other functions. Notice that main has a type, a name, has a pair of parentheses which we'll explain shortly, runs some code, and returns a value. Any other functions we want to make will follow this basic structure. To illustrate making a function in our program, let's make a function called isLegal. This function will decide if a move is legal for a given board state. Firstly, we need to give our function a return type. Since a move is either legal or not legal, we will have our function return a Boolean value. Then, we name our function isLegal. After the function name, we need to specify what arguments, if any, the function accepts. Function arguments are variables representing data we want that function to take as input. And we specify any arguments the function takes between parentheses after the function's name. Here, we will specify 4 arguments: a board state, an x-coordinate, a y-coordinate, and the number we want to put at the specified x and y coordinates. Once we have specified the function's return type, name, and argument list, we put the code executed by our function between curly braces after the function's signature. For now, we'll just have our isLegal function always return true, effectively making all moves legal. We'll add more code here in a moment to make our function actually check if a move is really legal. Now, let's learn how to use functions by using our isLegal function to check to see if a move the player is trying to make is legal. We'll go down to the game loop we wrote in the last video and add an if statement in the part of the code that lets the player modify the board. In the condition of the if statement, we'll call our function and pass to the function our current board state, the x and y coordinates of the move, and the value we are trying to put at the x and y coordinates. If the move is legal, then we update the board state accordingly. Otherwise, we will print a message to the user letting them know that the move they are trying to make is illegal. For now, our isLegal function is just always returning true, so our program should think that any move we make is legal. Running the program confirms that it still allows us to make moves, even illegal ones. To make it so our program does not allow us to make illegal moves, we need to add some more code to the isLegal function. Checking if a move is legal is actually a fairly straightforward process. We will first perform a series of checks to see if a move is illegal, and if any of those checks pass, then the function will immediately return false. If all of those checks fail, however, then we know that the move is legal, so we can return true. Let's now think about how to check to see if a move is illegal based on the rules for Sudoku. In Sudoku, all numbers 1 through 9 must be placed on the grid such that each number occurs only once in each row, once in each column, and once in each 3x3 subgrid. So when checking if a move is illegal, We just need to see if the number we are trying to place at a certain grid point already exists somewhere in its row, column, or subgrid. Checking rows and columns is very easy. We can do this with some for loops that check each element in the row and column that we are trying to place a number in. If any of those numbers it checks are equal to the number being placed, then we immediately exit the function by returning false. Checking subgrids is a little more challenging, but there's a clever way to do this by exploiting some properties of integer division. In integer division, the result is truncated after the decimal point because the result needs to be an integer. This is known as floor division because no rounding takes place, we simply discard any digits after the decimal point. Because x and y are integers, we can find the grid coordinates corresponding to the top left square of the subgrid we are in by dividing x and y by 3 and then multiplying them by 3. We can then use two nested for loops to loop through all of the grid squares in the subgrid and test to see if the number we are trying to place there is already in that subgrid. Running our program again, we can see that it does indeed prevent us from playing illegal moves. We're not quite done yet, though. There's still one subtle bug in our program that we need to take care of. Observe what happens when we try to place a number in a square that is not in the grid, for example K7. To fix this, we can simply add an additional check to our isLegal function. If the x and y coordinates are out of bounds, then we will return false. Here, we will use the OR operator to make the condition true if any one of the Boolean expressions in our condition is true. While we're here, let's add one more check to make sure the number we are placing is between 0 and 9. This will prevent us from doing silly things like placing the number 200 in a square. Now, we have a program that allows the user to make only legal moves on a Sudoku board. We are one step closer to our final application. In the next video, we will continue adding to our program by adding code that will help format the output of our program to make it more visually appealing. Until then, feel free to play around with this program. I'm sure you can come up with lots of cool features to add to your own version of this program. Feel free to share your progress with everyone down in the comments. Thank you for watching, and I will see you next time.